Okay, wrapping up linear functions. Tomorrow we have a test to assess the individual students' understanding of our linear functions.
We do have tests tomorrow?
Tomorrow is the test, and the test will look very similar to this.
Tomorrow, you mean Monday?
Monday. All right, so number one, it says here that we have an activity called rolling down the track, where students roll a toy train at an incline and measure the distance it moved from the bottom of the incline. The following data was collected. So if you look here, they give us a table of values. The first column we have here represents the height of the incline. So we have 5 centimeters, 10 centimeters, 15, 20, 25. The second column represents the distance that the toy train traveled from the bottom of the incline. In other words, how far it went. So the first time they did this, they had an incline of 5 centimeters, and the train traveled 30 centimeters. Then they raised it a little bit more to 10 centimeters. Notice that the train traveled a little bit further here. Now it's 45 centimeters, the distance, and so on and so on. So the first thing we're going to do is part A, and that's to sketch a scatter plot over the appropriate domain and range. So we're going to use this graph paper to sketch each of these ordered pairs. But you'll notice there is no numbers down there on the x or the y. So we're going to have to figure out what are we going to count by. So down at the bottom, first of all, these x's. Those x's are going to represent the height. So let's go ahead and start there. All these x values are going to be representing the height. And when I say height, we're talking centimeters here. So in parentheses, I'm going to put centimeters.
We can count by twos.
All right, so you'll notice here we need to make sure we can get all the way to 25. And if I count by ones, I won't make it all the way to 25. So the suggestion was to count by twos. And that sounds like a good option because if I count by twos, that'll definitely get me all the way to 25. So we're going to go here, go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so on. All right? 2, 4, 6, 28, 30, so on and so on. So we're counting by twos. Now that's for the x's. For the y's, a little different here. Notice that the y values, this time they represent the distance. So out to the side, I'm going to put down that they represent the distance.
By 10.
However, notice we got to get all the way up to 122. And if I count by twos, I'm not going to make it this time. So we got to count by something a little bit bigger here.
10.
Tens. Will that work? If I count by tens, will I make it all the way up to 122 or past it?
Yes.
All right, let's try it.
Wait.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
Yes, you are.
All right, so it looks like we're going to be in good shape. So there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, and so on and so on. All right, so you'll notice here we have enough room to graph or plot each of these points. So let's go ahead and find the first one. We're looking for 5/30. So we're going to find 5/30. Of course, 5 would be between the 4 and the 6, so I'm looking right here. Here's the 5. And then I need to go up to 30. So that would be, where's it at? 10, 20, 30 right here. So there's the first point, 5/30. The next one we're looking for is 10:45. So let's come over and find 10 and then the 45. Of course, 45 is going to be between the 40 and the 50. Now I'm looking for 15 and 80. So let's come over here and find 15 and then find the 80. The 80 right about here. Next one is 20, then 93. So let's find 20 and then the 93. So it's going to be just a little bit higher than 90. And the last one we have is 25 and 122. So let's find the 25 way over here. Look at that, 20, 22, 24, 25, and 122.
Are we doing this all in class?
Just a little bit higher than the 120. All right, so here's our graph. All we did was plot each of these points. So you're going to have one just like this on the test. You'll have different numbers, but same idea. You're going to have to tell me what you're counting by, and then plot the points. So at this point, we're done with the sketch of the scatter plot. We've just completed part A. Now we're going to use this to answer some of the other questions. So let's go on to part B here. Part B asks us what parent function can be used to represent this data. And now, if you've forgotten the parent functions, I've got them all up there on the wall. So if you forget, you can always look over there. So Emily, are we looking over here at the wall? Everybody look at the wall here. We have a choice. We have linear, we've got quadratic, we've got square root, we've got absolute value, and we got some of those others. The question is, these points, what are they looking like?
Linear.
Linear. They look like a line. So that's what we're going to put for part B here. This would be a linear function. Why? Because all the dots are lining up what it looks like a straight line. All right, so for part C there, how would you describe the correlation? Underline that word for me right there. Correlation. All right, so when we talk correlation, there were three types of correlations that we talked about. We had a positive, we had a negative, and we had a no correlation. So the question is, which of those three choices am I looking at in this graph that I have here? Positive, negative, or no correlation?
Positive.
Positive. And how do we know it's positive?
Because it's going up.
Because it's going up. It's increasing. So right here we're going to put positive. What we're looking at is a positive correlation. Now on the test tomorrow, you could find that the dots are going, Monday, the dots are going down. And if the dots are going down, then you would say it's a negative correlation. What if the dots are all scattered all over the place?
No correlation.
And it's a no correlation. So make sure you're paying attention to the pattern of your dots there. All right, next one, D. They want us to sketch a trend line on these scatter plots. So let me start there. Let's sketch a trend line. So let me go back to my graph, and we're going to draw a trend line. Remember, a trend line was the line that goes through the points. Doesn't necessarily have to touch all of the points, but it's a line that goes through the points. This is a line of best fit, or a trend line. Okay, so we're going to put that on our graph. That's the first part of part D. The second part of that part D says to find an algebraic rule to represent the trend line. In other words, what would be the equation of this line that I just drew here? Y equals what? Well, the easiest way to find that line or that equation is to use your stat button in your calculator. So that's what we're going to do next. So everybody get your calculators out, and let's go to stat, edits. Everybody go to stat and then edits. Stat and edits. And the first thing we're going to need to do is in L1, we're going to need to put this values here, the 5, the 10, the 15, 20, and 25.
Y
L1.
equals.
Wait. Let everybody get a chance here to put it in there. In L2, we're putting the 30, the 45, the 80, the 93, and the 122. I'm going to walk around and check to make sure everybody gets the right equation, so make sure you are actually putting this in your calculator. Don't wait for somebody else to do it for you. Remember, once you have that in L1 and L2, what we do next is we go to stat calc, and you got to remember what we use, which number we use.
4.
Number 4, linear regression. So select number 4. Remember, you are going to have to hit enter a couple of times before it gives you the equation. And we're going to look, and what we should see is an equation that looks something like this. Y equals blank x plus blank. So I need two numbers here. Let me walk around here and see what numbers we're coming up with. See if everybody's getting the same numbers. So where's yours? All right. Okay. Got a couple of working on it. Okay, those of you that actually have it look like you're coming up with the same numbers. So double check that for me. One number looks a little different. All right, so it looks like the majority of us have the same equation, and that equation is y equals what?
4.64x plus
4.64x what?
Plus 4.4.
Plus 4.4. So this is the equation we get using our stat button. So if you don't want to do it by hand, just use your calculator. And that's probably because when you did in your stat button, you missed a number or you typed in one of the numbers.
I don't even remember how to do it by hand anymore.
Because
we can use our calculator, right?
Yep. And that's the fastest and easiest way to do it. All right, so let's go to E. Now that we have that equation, it's going to come in handy to answer the next couple of questions here. E asks us to predict the distance the train would travel if we were to have a height of an incline of 30 centimeters. So now that we know the equation, let's use that equation to answer the question. So now go to y equals for me. Go to y equals. And I want you to type in that equation. I want you to type in the 4.64x plus 4.4.
I already got it.
Put that in y equals.
I think I can get like this also.
Yes, you can do it like that.
Where's the y at?
Y equals.
Actually put it in the number.
Put it in y equals.
Never first graph.
Well, we could hit graph, but instead of looking at graph, I want you to look at the table instead, because it's going to be a little bit easier to find if you look at the table. So go to your table. Now let me remind you what you're seeing in your table. You see two columns of numbers, right? The first column, just like the first column we had over here, the first column represents the height of the incline. The second column you see on your calculator, that represents the distance. So when we're answering that, we need to keep in mind, the question was predict the distance. So we want to know what is the y when the height, or the x, is 30. So look on your calculator, look in that first column, and see if you can find the number 30. You might have to go down a little while until you get that 30. And the number you see right next to that, 30, is what?
143.6.
143.6. So if we had to take a guess here, we would guess that that train would travel 143.6 centimeters if we were to raise the height of the incline to 30 centimeters. Now, does that mean it's going to be exactly that amount? No, not necessarily. But it gives us a ballpark figure. That's about as close as we can get there. Letter F is pretty much the same thing as E. We're going to use that calculator again. However, notice this time they're asking us to predict the height. They want to know what's the height. So what is the y of an incline? Oh, wait. Predict the height of an incline. So this time we're looking for the x if the train were to travel 150 centimeters. So now we're looking for 150, but we're looking for that 150 underneath the y column. So see if you can find that 150 underneath the y column. And you may not find it exactly, but we're going to find one pretty close to 150. What did you find next to 150? 150. Okay, so that's probably the closest we're going to get. What's the number you see right next to that?
32.
32?
So with this question, I would have to put that in y equals, right?
Not necessarily, because just like you used the equation, this time you would put in 150, but you have to put in 150 for the y and solve for the x. So it'd be a little more work for you. It wouldn't be quite as easy as the other one.
So that's probably easier.
Yeah, and that's why I'm saying, I'm trying to give you all the easiest way to come up with these answers. And that's the whole purpose, guys. That's the whole purpose of finding this trend line here. Because once we have that trend line, it helps us make predictions. That way we don't have to do everything by hand. That's what the test is going to look like on Monday. Yes.
And just all these questions?
Yes, like I said, I'll change a couple of numbers here and there.
Oh, so this is the review?
Yes, we're going to do some more.
This is the review?
This is the review for the test. Absolutely. All right, so that takes care of the first page. So again, all we did was use the calculator to do that linear regression to come up with this equation. Once we have this equation, we can use it to answer E and F. So you're going to do the same thing for me on Monday on the test. Use the equation to answer E and F. Now, number 2, there's only one part to number 2. It says here that the following table shows the amounts of hours worked at selling the refreshments during a soccer season and the amount of money received. Using the graphing calculator to transform the linear parent function and determine the trend line to represent the relationship hours as an independent variable and the receipts as a dependent variable. Now, that right there makes it sound very complicated, guys. So basically what we're going to do is the same thing we did with number 1. All we're going to do is use our stat button and do a linear regression so that we can come up with the trend line, or that equation that says y equals something. So all we're going to do is put in the numbers. The question is what numbers, because there's 3 columns of numbers, and we only need 2. We need something L1 and L2.
Hours and receipts.
That is correct. So all of these numbers are going to be under L1. All of these numbers right here are under L2. Okay? So go ahead and do that for me. Let's go to stat edits. And let's get all those numbers in. I'll give you some time here to get all those numbers in. And then just do the same thing we did on number 1. Do that stat calc, linear regression. Let's see what we get.
Okay.
Now be real careful. Make sure you don't miss any numbers.
Do I have to write them just like that, how that is?
Just like you see it. Now, of course, you don't have to use a dollar sign. There's no dollar sign, but yes, type in the numbers like you see it. Again, guys, be careful. Make sure you don't accidentally miss one of the numbers. Make sure you type them in just like you see it, because one little mistake is going to make the whole equation wrong. You've got to be extra careful.
Can I say it?
No, not yet. I'll let you say it in a minute. I'll let you say it. Everybody get a chance to put 3 numbers. But you can write it on the. That's about right.
I have to write the whole thing?
If you get a lot of decimals, let's just go 2 decimal places.
How come I get the zeros on staying on the
On the 100, it really is because it's the same thing. It's the, when you say $100, you can put 100. You don't need 100.
this one right here?
Oh, because the 0 is not necessary.
I didn't notice that.
Can you drag this back out?
Yep, stat calc. Number 4.
Along the line.
Yeah, remember, you're going to get a real long decimal, but that's okay. We're going to go ahead and just go 2 decimal places. So don't write the whole decimal down. Just go 2 decimal places. So far, it looks like everybody's excited. Looks like we're all getting the same numbers. Looks like everybody's typing it in correctly here.
This part, one,
I think just about everybody has got it already, so let's go ahead and take a look at the equation that we came up with. For the first number, what are we going to use for the first number? Again, we're going to go 2 decimal places. What did you get to 2 decimal places?
36.46.
36.46. All right, now don't forget about the x after that.
Minus
And the second number you have is a negative number. And what is that negative number?
negative 57.95.
57.95. So this is the equation or that trend line for this particular set of data. So just remember on that test on Monday, when you see this, we don't need these numbers right here. The ones that are important are the hours and the receipts. All right, so that was pretty easy. There's just one thing using your stat button to do a linear regression. All right, then let's go to number 3. Number 3 says Jason competed in a cycling contest. He starts at the Cedar Creek, which is 250 miles from the finish line. Jason, his average speed is 10 miles per hour. So that's how fast he goes. Every hour, he goes 10 miles. So after 1 hour, he's traveled 10 miles. After 2 hours, how far has he gone?
20.
20 miles. After 3 hours, he's gone 30, and so on and so on. Okay, so that's what we're saying here. So for part A, they want to know what is the independent and what is the dependent variables in this particular situation. So let me start with the independent. Independence. What is our independence? All right. In this case, the independent is going to be the number of hours. Our dependence. Our dependent is going to be our miles, the distance. Okay. Distance in miles. In other words, how far he's traveled depends. His distance depends on how many hours he's been cycling, right? Because if he's only cycling for 1 hour, then he's only gone 10 miles. But if he's traveled for 3 hours, well, then he's gone 30 miles, right? Every hour he goes, he goes a certain number of miles. So the miles depends on how many hours he cycles. B, part B, is this function discrete or continuous? Now remember, if you forgot discrete and continuous, I still have it on the board over there. Continuous and discrete. This particular one is considered to be continuous, and that's because we can have half
Of a mile.
half of a mile. We can also have half of an hour. He can travel for 1.5
But
hours.
if it has
That's
people in it and you can't,
that, very good. You remember. Things that we cannot have half of are things like people.
what if it had like people and miles?
People, well, that, again, that would be discrete because we couldn't have half of a person.
Oh, so it has to be, we have to have half of both?
Right.
That's what I think.
All right, the last one, or part C here, they want us to complete the table of data. So notice here, 0, at time 0, at the very beginning,
0.
what is his distance from the finish line?
0.
No, from the finish line. How far is the race?
Come on.
Read what it says here, guys. He's competing in a cycling contest. He
250.
starts
Oh, 250.
250. So the distance from where he starts to the finish line
250.
is 250 miles. So that's what we're going to start off with. At time 0, at the very beginning of the race, he's 250 miles from the finish line. All right, so let's go to the next one. After 1 hour, he's been cycling for 1 hour. How far is he from the finish line now?
240.
And how do you know he's 240?
Minus 10.
Right, because you're taking away 10, because he goes 10 miles every hour. So now it's 240.
230.
The next one, he's gone 2 hours now. So now he's a little closer to the finish line. Now he's 230 miles from the finish line. The next one, what should the next one be?
210. I mean 220.
220. The next one should be
210.
210, 200, and then so on and so on. Okay, so every hour that passes, he gets 10 miles closer and closer and closer to the finish line. All right, so that completes our table. Any questions on number 3? All right, so let's take a look at the next page.
Next page. Next page is this. Oh yeah.
Next page,
They have different. Oh, you just have the answer.
part D. Last page here, part D. Graph a scatter plot of the data over the appropriate domain and range. So basically, all we're going to do is take this table that we came up with, this thing right here, and we're going to put it on graph paper, kind of like what we did with number 1. So let me come over here. First of all, down at the bottom, the x's. What did those x's represent? We have it over here. The x's represented the number of hours. Let me come over here. Down here we got hours. Now in this particular case, our table only went from 0 to what?
0 to
Look at your table, guys. 5. So can I count by ones on this one?
Yes.
Yeah, it'd be okay to count by ones.
I thought we were doing this. Oh no, I don't want to.
5, 6, 7. So we're going to have a lot of leftover room here, but that's okay. It's okay to count by ones, because in this particular case, we're only going up to number 5. Now let's look at the y values. Let me come back over here to the table. The y values represent the number of miles. And the biggest number we have in this table is 250. Okay, so let me go back here. First of all, we said that it was miles. And we need to make sure that we can get all the way up to 200 and, what was it, 50? So are we going to get 250 if we count by tens?
I don't think so.
Let's try it. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
No.
110, 20, 30, 40, 50, 60, 70, 80, 90,
Count
100.
by 15.
That's 200. But if you notice here, the biggest number we had in our table was 250.
Count by 20s.
Yeah, 20s.
20s?
20.
Then 20s will actually do it, right? So let's go ahead and do that. Let's do by 20. So let's do 20, 40, 60, 80, 100, 120, 140, 60, 180, 100. Then again, 220, 40, 60, 80, and so on and so on. And we need to do it this way to make sure that we can get all the way up to that 250 mark. All All right, so we've got our graph set up. Now it's just a matter of going in there and plotting each of these points. And the first point we had was 0, 245. So let's come over here and find 0, right here, and 245. 245 is going to be right slightly above the 240 mark. Right about there, 245.
And then have
Let's see, the next one in our table was what?
245.
Oh, my bad. What was it again? 250. All right, so let me go back and fix that. And that was 250, so I'm still pretty close. It's going to be in the middle there. 250.
Oh yeah, it's in the middle anyways, right?
Yep. The next ordered pair we had was 1 and 240. So let me find that one. 1 and 240. That's going to be right here. 1 and 240. The next one we had in our table was 2 and 230. So here's the 230 is going to be in the middle there. Oops. The next one is 3 and 220. 320. The next one is 4 and what?
410. 220. 210, I meant.
210.
I'm all confused.
And then the last one we had was 5 and
200.
200. So then our graph looks something like this right here. By the way, notice what those dots are doing. What's happening to the dots this time?
Decreasing.
They're decreasing. Why are they going down this time?
Because the more miles you do, the less you
The
have.
closer and closer you get to that finish line, right? All right, so we got our graph complete. Now let's answer some of these questions. Notice on E here, determine an algebraic rule. That's a fancy way of saying write an equation. Write an equation that represents the data and sketch a trend line on the scatter plot. So let me go over here and real quick.
Y equals again?
Yep. So let's go ahead and sketch that trend line. So that's that line that goes through the points. So it looks something like that there.
It's decreasing.
That's right, it's decreasing. So I just drew the trend line, but they also asked me to write an algebraic rule, which again, that's just asking you to write an equation.
Isn't it Y equals
So let's go to
10x
that stat button.
minus 250?
We're going to find out. Let's go to that stat button again. And let's put in those ordered pairs that we had in our table over here so that we can do that linear regression. So in your table, in L1, we should be putting 0, 1, 2, 3, 4, and 5. And in L2, we're going to be putting these numbers over here, the 250, the 240, the 320, 220, 210, and 200.
Oh, so right. Oh, negative 10. Oh,
We're doing that linear regression so we can find the equation.
And then calc.
Yeah, do that calc. We're looking for this thing right here, y equals something. Now, if you get a decimal, just like we did on that other one, we're just going to go ahead and go 2 decimal places. I don't know if you got a decimal or not. No, no decimal.
We have something. And then
All right, what are we coming up with? What was the equation?
Y equals negative 10x plus 250.
Negative 10x plus what?
250.
2.
I gotta mix that.
Y equals negative 10x plus 250.
I thought it would be 10x minus 250.
Now, by the way, guys, notice these two numbers here, they look familiar. This 250, what does that 250
The
represent?
miles that is far away from.
How far away from the finish line we are. What about this 10? What does that 10 represent?
The miles is talking every hour.
That's right. It's how fast he's going, isn't it?
Yeah.
So let's use that to answer these next couple of questions. Letter F here says, what is the slope? Which one of these numbers in the equation is the slope?
Negative 10.
Negative 10.
And it represents the
What does it
miles.
represent? I just told you what it represents. It represents how fast he's going. Okay? It represents his speed. It's the speed of the cycles.
Why can't it be the number of miles we're talking about?
Well, it's the same thing. How many miles he's going every hour, which is the speed, right? Miles per hour. Just like on your car. Miles per hour is the speed of the car. Same thing. But if you were to put that on the test, you'd be correct. That is the same thing.
What does that say? Speed of?
Speed of the cycles. How fast he's going. How many miles he's going every hour. The y-intercept. If we look at the equation over here, which number is the y-intercept?
250.
The 250. So 250 is the y-intercept. And what does that number represent? I just told
Number of
you.
miles you have to travel.
That's right. It's how far. It's how far he is from the finish line.
What website do you post?
How far from the finish line he is. That's what that 250 is. All right, we got two more here. Actually, three more. H. What is the x-intercept or zero of the function, and what does it represent in this situation? What is the x-intercept? Now notice we don't quite have the x-intercept yet, guys, and there's a couple of different ways that we can find it.
Make it
When
go.
we say x-intercept, basically what we're saying is what number would I have here when this number is a 0?
250.
In this case,
Oh, and that's a 0.
yeah, when this over here is a 0, what would this number be here?
Oh, we would do.
We can find it a couple of different ways. One way we can do it is to use the equation and to replace this y with a 0 and solve it for the x. And I think that's the route I'm going to go in this particular case. So remember, the equation was what again? Y equals
25.
negative 10x plus 250. So all I'm going to do is replace the y with the 0. And I'm going to solve this thing for x.
25.
So I'm going to start by moving that 250 to the other side, subtracting it.
That's what we would do when it gets x.
Yep. Anytime you're looking for the x-intercept, all we do is replace y with a
Not
0.
my brain.
Then I'm going to come over here and divide by a negative 10. So negative 250 divided by a negative 10 results in a 25.
How did you get that?
What's a
Because
negative
25 times
250?
10 equals 250.
Negative 250 divided by negative 10 is a positive 25.
That equals 1 second. So you want to change
So the
it?
question is, what does that number mean? Let me go to the table so you can see
Hold on,
it.
hold on.
Got it.
Equals negative 10. Yes, I got it.
Let me go back to the table so you can see over here. So basically what we're saying in the table, oops, one too many. So over here I'd have a 25 here and a 0 over here. What would that mean? It takes 25 hours
to complete the race.
to complete the race. That's exactly what it means. So it takes 25 hours for us to finish the race. Okay.
That's a lot.
All right, so let's come over here and write that in for part G. I'm out of room, so you go ahead and put it. What does it represent? It represents, it means 25 hours to complete the race. So put that in there for me.
Part
This
G,
is
that's
still
part
H.
8.
This is still part H. This is still part H. It takes 25 hours to complete the race. 25 hours to complete the race. $25 to complete the race. All right, last two questions here. I, how far was Jason from the finish line in 12 hours? Well, let's use our equation to figure that out. And the equation we had was y equals negative 10x plus 250. So everybody go to your y equals button. Go to y equals. Put that in there for me. Negative 10x plus 250. Negative 10x plus 250. Put it in your y equals.
130.
Once you have it in y equals, you're going to go to your table, second graph. You see a lot of numbers in that table. Don't forget, the first column you see represents the number of hours. The second column you see represents the number of miles. So what we're looking for is 12 underneath the first column. And what do you see right next to that 12 in the first column?
Wait, what did you say?
We're in y equals, you already typed in the equation, right?
Oh, yeah, it's 130 miles per
And right next to the 12, we're looking at 12 here.
Oh, I I think I'm looking at.
So right next to 12, we see, what's that number again?
130.
130. So in other words, he's 130 miles from the finish line after 12 hours starting the race. 130 miles. The last one is the opposite of number or letter I. J says, how long has Jason been cycling if he was 30 miles from the finish line? So again, you've already got the equation in y equals. So you're going to go to your calculators again. You're going to look in your table. And in your table, you're looking for 30. Just make sure you're looking for 30 underneath the y column. Because the y column are the number of miles. So 130. And what do you see right next to that 30? 22.
I'm a smart little cookie.
22 hours. In other words, how long did he travel? He's been on there for 22 hours. And now he's only 30 miles from the finish line. Okay. All right, guys, that wraps up the review. Remember, this test will be on Monday. It'll look very much like this thing here. So if you study this, you shouldn't have any trouble.